Section 2.3, Finding Domain and Range. Finding domain and range. The solutions of an equation in two variables consist of a set of ordered pairs, such as x, comma, y. A set of ordered pairs is called a relation. When a set of ordered pairs is such that no two different pairs share a common first coordinate, we have a function. The domain is a set of all first coordinates, and the range is a set of all second coordinates. So to recall from our previous section 2.2, a function is a special type of relation between your x's and y's where your x's may not repeat, but your y's may. And we used an analogy of thinking of people and relating people to a birth date. And what we're just saying right now is that this function, it can be made up of an input and an output called a domain and a range, where your x's are your domain and your y is your range. So let's take a look at this first example. Find the domain and range of the function whose graph is shown below. So let's take a moment to write down our domain and our range. So let's write the set that makes up our domain. Our domain, we said, is our x of our point x comma y. So let's point out our x's. We have -3, 1, 3, and 4. So our domain would be -3, 1, 3, and 4. What would our range be? Let me erase our markings. Our range would be the y. So the second number listed, such as 1, -2, 0, and 5. Let's write them from smallest to largest, so -2, 0, 1, and 5. That is our range. Example. For the function f whose graph is shown at the right, determine each of the following. A, the number of the range, that's supposed to be range, that is paired with 1 from the domain, that is find f of 1. B, the domain of f. C, the numbers in the domain that are paired with 1 from the range, that is find all x such that f of x equals 1. And D, the range of f. Let's start with A. The number in the range that is paired with 1, that is find f of 1. So what we're saying is what number, question mark, what number is the outcome when I plug in a 1? So if I look at 1, I have this point, 1, comma 2, right? So if my x is 1, so I'm going to write this here, 1, comma 2. So if my x is 1, then my outcome, my answer is 2. So my answer to this question, f of 1 is equal to 2. That is my answer. Okay, B, the domain of f. Let me erase my markings from the previous question. Okay, B, the domain of f. The domain is what are all the x values? So we see a graph, and all of this is our graph. And we see that with that, we have x's. We have x's starting at -5 and ending at 3. So if we look at our graph from left to right, our graph, the lowest number along our x's is a -5 and a 3. So my domain would be those numbers enclosed by those values. So if I want to write it as set builder notation or using inequalities, this would be x such that -4, -5 less than or equal to, since it's a closed circle, let me erase that marking. Yes, it's a closed circle. So less than or equal to x, less than or equal to 3. If you want to write an interval notation, which is my favorite, because we just see where do we start and where do we end. Interval notation would be -5 to 3. That is our domain and our range. I'm sorry, our domain. Let's continue with C. Let me erase my markings from our previous question. C. The numbers in the domain that are paired with 1 from the range. That is, find all x such that f of x equals 1. So I want to find all the values where my answer, my outcome, my y is 1. Well, I see 1 is here, and the only number that pairs with the 1 is right here, right? That's the point -4, comma 1. So I want to see, hey, where is my output? Where is my answer 1? That happens only at the point -4, comma 1. So this means f of 4 is equal to 1. And that is our answer. Or if we want a more detailed answer, or if you're not happy with just that, you can say f of x equals 1 when x equals 4. That's what we're looking at. All right, last question, D. The range of f. When you think of the range, you know you're thinking about your y, your outcome. When you're looking at your graph, you should look at your graph up and down. How far up does it go? How far down does it go? So if I look at my graph, looking up and looking down, we see that my highest peak along my y is a 4. The lowest peak along my y-axis is a -1. So this is a description of our range, which is our y output. All right, so for your range, remember, think of your y's. Our answer, our range would be between -1 and 4. So in interval notation, -1 through 4. In set builder, I guess we can write it as, we're talking about our y's. Instead of x, we'll write y such that -1 less than or equal to y less than or equal to 4. Remember, when we're enclosing a value, we use that compound inequality for our number line. Okay. So what I want to emphasize here is domain and range. For B, your question with domain, just like D, I want to emphasize when you look at your domain, you want to look at your graph for your y's, and you want to look at your graph from the left and to the right. How far left does it go? How far right does it go? That's what you're looking for in a domain. So parts B and D are questions that you'll see again in this chapter. Moving forward. So in the first question, our first example, we had a picture to where we find the domain and range. How do we find the domain and range algebraically when we're only given the function? Well, mostly domain. How do we find it from our equation? Well, this is how we go about it. When you have a domain, you want to think, what can x be? What are my restrictions? There's two common things that leads us to restriction. One of them is a fraction. What can this number on the bottom never be? Well, if it's 0, it would be undefined. So we never want it to equal 0. So when you're trying to find the domain of a fraction, You want to go ahead and solve for 0. Solve the denominator. Equal to 0. Set it equal to 0, and that will tell you what x can't be. Or you can also set it to x not equal to 0 and treat it the same way. Also, we have a square root. So just to remind you, since I know this is something that we tend to forget, I know I can take the square root of a positive number, such as square root of 1, we get 1. I can take the square root of 0. The square root of 0 is just 0. But I cannot take the square root of a negative number. We'll work within the feature that leads us into a whole separate number system called imaginaries or complex numbers. But for us, that would make it a problem. We can't deal with negatives. So whatever argument, whatever expression we have inside the radical, it needs to hold to be equal to greater or equal to 0. Because it needs to be bigger than 0, meaning positive, but it is okay if it equals 0. Hence why it's greater or equal to. All right. So those are your two big big things to consider. Keep this in mind when you're being asked for the domain given only an equation. Okay, let's go ahead and continue. Find the domain of f of x equals absolute value of x. So we want to think, what can x be? This one's different, right? So you want to ask yourself, what can x be? And then go through a list. Can it be negative? Yeah, I can take the absolute value of a negative. That just gives me a positive answer. But regardless, I can get an output. Can it be positive? Yeah, that's not a problem. The absolute value of positive 5 is 5. And fraction decimals will also work. So it doesn't seem like we have a problem, right? And 0 also works. So for this one, our answer is all real numbers. In interval notation, we write it as negative infinity to infinity. Next question. Find the example or find the domain of f of x equals 3 over 2x minus 5. Okay, here I have a fraction. Whenever you have a fraction, red light should be turning in your brain because you know that you have to be careful. Your domain here is restricted. It's restricted to where this equals 0 because it can't equal 0. If I have a situation where since we have a 3 on the top and I have a 0 on the bottom, that would be undefined. And we don't want this situation. Okay, so I need to find out where 0 would happen. That would make it so x can't happen. So let's solve for this denominator. So we have 2x minus 5, solve for 0, plus 5 plus 5. 2x is equal to 5, divided by 2, divided by 2. We're left with x is equal to 5 over 2. So this means that x cannot equal 5 over 2. Any other number is fine, just this is our restriction. So our domain is all real numbers except 5 over 2. Now that we understand the concept of it, we have to be careful as to how we write it. Writing in notation, for me, always requires a number line, so I can see what I'm working with. And what we're saying is it can be any number except 5 over 2. It can be any number greater, any number smaller. I truly need the number line so I can interpret this in interval notation and set builder. So in set builder, Our answer would be x such that it would be negative infinity, or I'm getting confused with my notation. X would be less than 5 over 2, and x would be greater than 5 over 2. So x is greater than 5 over 2, or x is less than 5 over 2. In interval, it would range from, so we read from left to right, so we go for negative infinity and to infinity with that break at 5 over 2. So we go from negative infinity to 5 over 2. Infinities always have a parenthesis, and because that 5 over 2 is not included, it's just a stopping point, it also gets a parenthesis. Union, 5 over 2 to infinity. All right. Now, like I said, we can reason our way through it, and it makes a lot of sense. But writing in set and interval notation, at least for me, I do need a number line because I will make silly mistakes. All right, that's it for this section. We're just establishing a domain and range and how we can go about labeling a function with those characteristics. Thank you.